Hello, everyone. Welcome to our third meeting of the quarter. I'm just going to pass it on over to SCAD alum Jonah Reinhart to talk about facial rigs. So whenever you're ready, take it away.
Okay, I'm going to share my screen so we can see my screen. Can everybody see the Maya session? Okay.
Yep.
Okay, so probably a lot of the facial rigs that you've seen are like strictly joint and blend shape based. But like what I'm going to be showing you here is primarily based on a deformer called the Translate Uvn Deformer. So what that lets you do is it lets you slide the individual vertices along a NURB surface. So I'll show you what a NURB surface looks like here on the brow. So I've got just a simple NURB surface and I fit it to the shape of the character's head. So now when I take the control, well, I don't have it painted further up because that's where the hairline is, but you can see that the points just slide right along that patch. And so there's no joints involved in that, and there's no blend shapes. Like I could turn off the blend shape deformer and it still just follows along with that exactly. One of the reasons that this is really good for facial rigging is not only, of course, does it get you really great results right out of the box, like I don't have to fuss with much corrective. It's also what's called a parameterized deformer. So for example, I could have it's my tablet gonna work here. There we go. I could have a character with like a very long face and then a character with a very stout face. And so as long as I place the NURB surface on the same landmarks on the face, say for example, I just got, the eye line there. So if I just say, okay, I'm going to reserve the middle span to always sit here on the lid line. The next one above that is wherever the brows sit in their neutral position. And then I just have them all that same length offset from each other for the other ones. Because that's fit to the shape of the character, I can paint the weights on one character and just directly use those weights on another one. But because I've fit the surface to their face, those same weights will give me the same kind of visual result. Does that make sense? Good.
Yeah.
Okay, so another important part of that is having normalized controls. So on pretty much every Maya rig, let me just delete everything here. Not that. That'll work. If I had a character that was, even just with the same face shape, but bigger, the distance from the brow to the lid line would be greater for the big character than for the small one. So to take this brow control and move it down so it's on the lid line, this could be like -8, but then on a little character, that could be like -4. And of course, that can cause a lot of trouble if you just said, well, I animated some facial expressions or facial animation on this character, but because the values are different on my smaller character, I have to go through all this trouble of like scaling the Anim Curves and things like that. When ideally, I should just be able to copy this exact value onto the other face. So there is a way that you can do that. If we take a look at this rig, when I take this control down to -100, it's set up so that -100 is right here on the lid line. But if I were to decide if I were to put this on a bigger character and decide, okay, I need the distance that corresponds to 100 to be twice as much, all that I need to do is go to my guide, and I'll kind of explain how the guide is hooked up to the control in a minute. But I'll just adjust a single attribute, and you can see that the control is moving because now the value is still negative 100, but now negative 100 just corresponds to a larger distance. So that lets you have the same animation value, like in the channel box, on all of your faces. So you can just reuse animation really easily between all of your characters. And it's also quite nice to just have a nice looking value, because instead of it being based on the world distance where you get like, oh, it's negative 8.25 to bring it down to the lid line, now you can just decide on every character this is just negative 100. So every animator, if they step onto a new rig, they just know that that's correct. Have you guys seen something like this before with adjusting the channel box values?
I don't think I've seen that exactly, but I remember who is it? Andrew. Yeah, Andrew Solari. He did something like this a while ago. I remember watching him make it. It was for the crab rig that he was making.
Okay, yeah. So it's actually a pretty simple thing to do. Ooh, it's going to graph everything. I don't need everything. Let me get rid of all of this junk. So the way that it works is I have the control, and the control is not a standard transform node. Instead, it's a joint with the control shape, and I just have the display set to none so that you don't see that actual little circle with a crosshair for the joint. And I've connected up, where is it? I gotta graph that input. I have a connection. Did I just, no, it's right here. So I have that normal range attribute on my guide just for storage, and then I connect it into my control so that I can see it on the control itself. And then that gets divided by 100, just because it would be quite annoying to have big values here. So I just have like the regular world space values there, and then it gets divided by 100 and plugged into the inverse scale attribute of the joint. And so you might have seen the inverse scale attribute used on like a standard joint chain. I'll just set up 2 joints here. Because you've probably seen this effect that when I, scale up the parent joint, the child joint doesn't inherit that scale like it's a normal child, like a child shape, because it has this connection from the scale of the parent joint to the inverse scale attribute on the child joint, which kind of applies the opposite scale before it applies the individual translate, rotate, and scale on the child joint. So I'm just taking advantage of that so that I can scale up the parent space for my individual control, and then just apply that scaled space to my control so that it doesn't inherit that stretching. Because, for example, if I were to just create a control, put it into a group and scale up that group without having any sort of inverse scale set up, of course, the control is going to stretch. It's going to resize, which isn't what we want. So using that inverse scale, you can adjust kind of the size of the space that it moves in without adjusting the size of the control. other things on the face that might be of interest. So something that you might have found very annoying about a typical rig is usually you will set up like 3 controls, like on the brow or on the lip, and you'll have 3 joints. And the first thing you'll do is you'll paint all of the weight onto one joint until it looks good, and then you'll go and you'll split it out onto the individual ones. That's a pretty common way to do it, but I'm gonna have to delete this again. The trouble with doing that is that when you try to like smooth in between the individual controls, you usually end up with something that doesn't look so great. Like if I just had a straight brow and then you just had it weighted so that it moves down all uniformly, I've often seen controls that are weighted kind of like this, so that the inner control has 100% influence in this area, and the influence just stops at the center line. And so like the mid one would have influence that just stops out here. Is that a message from you guys, or is that some other notification?
Someone just joined.
Oh, okay. And so the trouble with this is, let's say you just wanted to take your brow and make it, a nice clean line to make it angry. You could put your mid control here and your inner control here and your outer control here, but you would end up with something that looks kind of like this. And so you could decide, oh, well, then I'll just make the weighting in between them linear, so it's just an angle. But then, of course, if you wanted like an arc like this, you pose the control to presumably create the arc, you end up with something like that. So what we do instead is we use a system where we do paint the entire brow onto one weight map. Let me see if I can show you that in Maya. Set that on the reference layer. So I've got that painted onto one layer. I'm sorry, just one weight map. And what we do is we use Anim Curves to actually do the splitting out. So you can see that this has quite a nice fall off through the middle out to the edge. And like the mid has quite enough nice fall off to the individual edges. The way that we get that to look so nice is we use, like I said, Anim Curves, which we just have stored here on this locator in this setup. So you can see how I have Anim Curves that are roughly shaped to the pose that I want each individual control to make. Let's say, for example, I've got this pose like that, and then I decide, oh, it's stopping a bit short of this outer control. So I could just look and say, oh, okay, this curve here is the influence for the inner one, and just move where that curve is in this graph editor, and you can see it's updated the weighting for the inner one. And what's really great about this is that I've adjusted it for the inner one, but the Anim Curve splitting system that we use guarantees that they will add up to that same individual weight map that we defined. So when we're working on a new character, like we never paint just brow in or brow mid or brow out or any of the individual, what we call like the micro controls. We would just do, okay, paint the brow, paint the lid, paint this, and all of that splitting out into the little controls that contribute to it just happens automatically. And if we need to adjust it visually, we can just adjust how they add up together using this graph editor. If you are interested in trying something like that out, I do have a video that goes specifically into splitting weights with an Anim Curve. Check out my blog at www.myname.com, yada yada. What else would be relevant to you guys? Something else that you might have noticed is when I was showing you the weight map for the brow, is this is not Maya's like paint weights menu for a skin cluster. This is just like the paint weights menu that you would use for a cluster. The reason that I'm using that instead of the skin weights is pretty much all of our face rig doesn't use skin cluster. The only place on like this demo file that uses a skin cluster is the jaw rotation. Everything else is using either that Translate Uvn Deformer, or it is using another sort of more simple custom one. For example, on the eyelid, which I'll talk about in a bit. The reason that it's really good to use something other than a skin cluster is when you use a skin cluster, if I were to paint the weight for my brow joints so that they took it from this sort of arced neutral shape to a very nice clean line when they go down, that weighting would not work so well going up, because it would try to like do the opposite distortion. So this middle part would fly up higher than these individual points rather than just moving uniformly together. Also, you can kind of see when I bring the brow down, this area in the lid is getting compressed, but when I move the brow up, this area is not getting compressed. And I know that you could have a system in Maya where you have a weight map for the lid and then a joint for the lid compression and a joint for the brow. But in a system like this, where you are just using what we call like weight holders, you can define a separate weight map for positive and negative, and then you can also have a different weight map for all three axes. So we have a unique weight map for the Translate Z, and then also the Translate X. You can see how when I translate in, it just kind of curves like this, but when I move up and down, it engages like all of this area on the forehead and the eyelid. Do you guys have any questions or things that you're interested in hearing about more so far? Can you guys still hear me?
Yeah, I used to hear you.
Okay. But everything is making sense?
Somewhat. Yeah.
This is
Okay.
all really like new to me, and it's super cool.
My brain hurts. Are you at Sony?
Yeah.
I mean, we'll talk about Sony probably at some point when I just talk about the Translate UVN stuff in more detail.
Oh, so you are from Sony? I don't.
No. I didn't. It did not work at Sony.
Oh,
But Sony uses a similar system to like the Translate UVN Deformer.
yeah, that's what I do know about them. I know they don't use regular skin weights for all their wacky faces and shit.
Yep. So another good thing about having a non-skin cluster based setup is you're not competing for weighting. For example, here, kind of around the eyelid, I could open the eye just like this using a skin cluster, because this is literally just a rotation from the center of the eye. But once I've done that, I've, pretty much assigned all of the weight that can be applied in this area of the lid, which would leave no room for weighting to allow for this kind of compression. But because those are two completely separate weight maps that don't have to add up to one, you have a lot more creative freedom when you don't have to worry about, oh, well, I've already used all the weighting that I could in this way, so this extra control that I want to add has to be, a sculpt or a cluster by itself, something unusual. That can really help for something like this. So like when I do this like set of vertices here is probably weighted like 95% because it's rotating pretty much 100% of the control. But then I have this control to widen the corner, and that looks like it has about, 10% or so, and it's got influence over this whole range. But because this inner control has a completely different weight map, I don't need to worry about, butting heads with the weight map that I've defined for the eyelid open control. And so this is just another example of the splitter. Like, you can see how the inner control is giving me a nice clean shape like this that passes through the middle. Same thing for the mid one. Once I add that in, and when I do the outer, mid, and the inner one together, they add up to that single clean shape that you get when you use the overall control. Squint is just another thing where you can see that we don't have to compete for influence. So I can just have this eyelid influence as much range as I want, and then this squint can push those same vertices with close to 100% influence.
Can you see what they look like together, like when both are active?
Sure. This one is not a very clean rig because I had to just do it in my free time this week before the presentation. But
no worries.
Yeah, but I can show you that. Yeah, so it's certainly not as clean as it ought to be. If I were to, spend the time to polish this, I would probably take this lower eyelid extreme and obviously smooth this out onto the cheek area. What else? On the mouth corner, we also use a NURBS patch. So you can see I've just got one that's kind of shaped to the contour of the mouth here, and then it just goes in a straight line out to the back. But what that lets me do is I can drag all these vertices and they kind of curve around the shape of that surface. And then when I go in, you can see that they compress along that same path. So you can accomplish this sort of stuff with joints. That's what we did on the Pony movie. We did not use a system like this with all of the custom deformers that make our life easier now. We just had basically a joint on each span that would have a set-driven key relationship with the control to kind of make it appear that it was working like this. But of course, one of the problems with doing a setup like that, where you have a joint on each span to get the behavior that you want, is now the weighting and the rigging that you've done is what's called mesh dependent. So if I had, a character with however many spans on their eyebrow, I could just, put a joint on each span, have those joints themselves slide along a NURB surface, and get a result that is similar, though not as good as the real custom deformer. But then say, for example, you have a character who's got differently shaped eyebrows where, modeling department says we need to make it longer, so we're going to extend it on the face by an extra 2 spans. Well, now the number of joints on that character is different than the one on your other character. And then maybe the numbering is going to get screwed up because you numbered in this direction, and then you've added new joints in that direction. So that's by no means something that you can't work around, because we had to deal with that on the Pony movie. Some characters would come up, it's oh, they have a unique brow, and we just have to go through the work of reweighting all of those individual joints. But in this system, the brow is just one weight map for going down. So if I were to add more topology to this character, which might not be a great example here on the brow, maybe here on the lip is where you might want to add topology. The witch on Brave, she has very defined little angular wrinkles on her lip, which would be, actual indented geometry. In our sort of system, you can just add that geometry and rebuild your rig. And what it does is it would detect, it says, hey, the last time you exported all of this weight, you had, 100 vertices, but now you've changed it. Now you have 150. And so it would give you the option to import all of the weights and all of the blend shapes using closest point on surface matching. So if I were to add like an extra span here for the wrinkle, it would just basically take an average of these two spans and apply it to that, which obviously saves us a lot of time because we have more freedom to change up the topology when it's necessary. Like if you have an old character that needs extra topology for, crow's feet, or maybe they have a scar over their eye, it's very easy for us to reuse all of the weight data from an existing character, even if the new character doesn't have the same topology. Anything else that is super relevant? A very simple thing here. Competing for influence, order of operations. So if you guys have used like the Kayla rig or looked at the Josh Sobel rigging tutorials, he shows off a pretty common Maya rigging technique where you have multiple copies of the mesh that each have like the rig for a specific area. Whoop. Tablet's getting a little bit wonky. For example, on Kayla, I might be misremembering, but I think that she has, a separate mesh for the skin cluster on her brow. She's got a separate one for the skin cluster on her eye, and then she has one for the lip controls, and then another one for the jaw control. And the reason that he has to do it that way is because each mesh can only have one skin cluster. So, he has multiple skin clusters that are chained together with blend shapes. But that can be annoying because then if you were to, be posing your controls, testing it out. Like, for example, I don't know who had asked me to pose these two. But like if I were just testing out my rig and I posed these two controls together, I would all of a sudden notice like, oh, my eyelid doesn't really balance well with my squint. But if those two are controls, the deformation is happening on two different skin clusters, it can be very hard to, be painting the weight on one and trying to figure out if that's going to look right once everything gets chained together. But on this system, because we don't really use skin clusters aside from in a few areas like the jaw, we're free to keep everything on this one mesh, which makes it a lot easier to work with. You don't have to think to yourself like, oh, is the brow on this mesh or is the lip on this one? Lip for the brow. Offset attributes. So when I was at Boulder, our facial rigging lead was somebody who had worked at Pixar for 20 years, and one of the things that he complained about a lot in Maya is that it is very difficult. It is sometimes difficult to create driven behaviors on a complex rig. So say, for example, what would be a good example on here? Maybe when I open up the jaw, the animators are like, oh, I want it to automatically pull in the mouth corner, 25%, or something like that. On a typical rig, because you've got a system sort of like this, where you got, your control, which goes into a big black box of Maya nodes and stuff in the node editor, and then is attached to a joint. If you want to just have like a set-driven key relationship where this control drives that one, you have to worry about, well, would, plugging the translate on this into a buffer group above this control, would that work with how you've set up all of these node connections? But in this system, there is very little of this sort of black box setup, because the only thing that we allow to drive the deformers are these individual attributes that are on the control. If I bring in the mouth corner, actually I can show you better on probably these two controls. Just bring those two in. So I've got my eyelid upper control, which is the big one, and then the sum translate attribute, which is a custom one that we added manually, is connected up into the offset translate of the left eyelid upper in control. That's the little one here. And so that connection just tells it when this one is moved to 100, move this one as if it was driven by 100. It's just kind of like moving a buffer group. But instead of having to add a buffer group for each driven behavior, we just use something called a math array node, which is just, like a plus minus average node. But it gives you different options for the operation. So if you want it to be driven by two different controls, kind of like a blend shape combo, you can just plug them into here, set this to multiply, and plug that into the offset translate. And then that would move the control as if you had just moved it by yourself on the control itself.
Are those offset, like translate, rotate, and scale? Are they do they work kind of like the offset parent matrix that's new, that came in Maya 2020, or is it kind of a little bit different?
It's a little bit different just because of the firing order. The main difference is the offset rotate. Like, I think the offset translate, if you just use that by itself, it would be identical to the offset parent matrix. But the best way to explain this. So if I take this lip control and it's gonna let me move it, translate it down, that's obviously just the negative translate y. But then if I were to take this lip control and rotate the lip out to do like a lip curl, I've set up a driven behavior to have these controls rotate it, because that's what makes visual sense. But I still want, down to be the negative translate y. If this were done with the offset parent matrix, then it would be like taking the control and just rotating a buffer group that's its parent. And so now the negative translate y would be along this direction. But because the offset rotate is connected into the joint orient, and the way like the joint orient gets applied is it gets kind of combined with the rotate and applied all at once, the translate axis remains unaffected because that offset rotate we used got applied on the joint itself rather than with an offset parent matrix or like an offset parent group. Does that answer your question?
Yeah, it does.
Okay. Yeah, so we've got like offset translate, rotate, scale, and then we just have like some rotate and some translate, which is just a straight addition of the translate attribute on the control itself added to the offset translate on that control. What else? Corrective blend shapes. We do a similar sort of thing. We would just use this math array node to define whatever sort of relationship we want between the control and that blend shape. So if you've used like the shapes plugin and done a combo, then it would create a multiply divide node, or maybe just a double linear node, which is just fine. But of course, those two can only handle 2 individual inputs. But with this one, because it's a math array, let me just connect these as dummy connections. I can just continue to connect as many drivers as I want. And if I set this to multiply, then it's going to work like a combo where I have multiple drivers. So for example, if I want a blend shape that's triggered when the jaw is rotated down and the mouth corner is up and the mouth corner is out in X direction, I could just plug in those 3 individual attributes with maybe like an Anim curve in between them to remap their values. And it would just multiply them all to give me one driver that's held on one node and use that as the blend shape driver. We also use the Anim curve splitting on the blend shapes. So, like I said, I don't have to do a blend shape on the brow in. I just do it on the overall brow down, and it gets split out in the same way that the deformer weights do, which obviously can save us quite a bit of time. Weight splitting logic. Rivets. Have you guys used rivets on your rigs before?
Yes.
Is there a tutorial going on?
Right now, like in this chat?
Oh wait, no, that was just on my end. My bad.
Okay. So like what sort of rivets have you guys typically used? Because there's a lot of different methods.
Like a scripting in follicles. That's what I do.
So you do like the one where
I get the hair sim. Ugh, what's that stupid shit called again?
the end hair follicle?
Yeah, end hair follicle. Yeah.
So you do the one where you take like a mesh edge, 2 mesh edges, and it runs the script and it just creates like a NURBS patch in between them with a follicle on it?
Yep.
Okay.
Or
Yeah.
I just used create nodes in scripting it in. So.
Okay. Yeah. There's been a pretty recent development in Maya where more of the deformers can run on the GPU, which makes a very big difference in terms of performance. So you could have a rig go from like 25 frames per second when they're not running on the GPU to running at 60 frames per second when they're on the GPU. One of the requirements, though, is that you can't, if I have my, delete everything, my end result mesh, I'm not allowed to have that mesh, the result one, be connected to anything. So connecting that to whatever node you use to generate those 2 edges Maya would say like, oh, I can't handle that on the GPU, and it would just evaluate the normal way. But there is a way around that, and that's using deformed rivets. So I can kind of show you the difference here. So like this would be an example of what you're talking about, where the rivet is based on the actual mesh face. And so in a situation like this where the jaw is open, that mesh face has kind of been, skewed along this line. And so the rivet locator or the follicle is actually askew as well. Like you'd probably still want the y-axis to be aligned up and down for whatever lip control you're riveting. But alternatively, what you can do is if you create a little NURBS patch, and I'll show this in the actual Maya session, and you just copy the skin weights from your face to that little rivet, it will follow along, with whatever percent rotation with your jaw. And I can show that on here. If I hide most of the stuff on the face. There we go, there are the rivets. Can you guys see those rivets through Discord? These little very small NURBS patches?
Yeah, they're visible.
Okay. The reason that I make them so small is that because we're copying weights from the mesh to this little patch, I don't want, one of the CVs here to copy from this vertex and then have this one over here copy from another vertex. So we just keep them very, very small so that they pretty much copy from the same point for all four CVs. You can see when I rotate the jaw, those little rivets get rotated with it. And so what we do is we just use some nodes in the node editor to generate that little rivet locator on there, which is what we have the controls attached to. But what's really good about having a deformation rivet like this is that you can inherit all of your transformations from it. Like if I have, my mouth corner is driven by one deformer or a blend shape, and then my jaw is driven by a different one, it can be quite annoying to try and get the rivets to inherit from both of them. But with this system, you can just have the same deformers that affect your face mesh affect those rivets, and they'll move along identically. But the really great thing, and the animators really love this, is because this is a little NURBS rivet, it can be deformed by, I think this is the wrong mesh as well. Here we go. Because they're little NURBS rivets, the rivets themselves can be moved around by a lattice deformer. So when I squish the bottom of the face, on a lot of rigs, you would see these controls just kind of get left behind. But because the rivets that they are attached to are getting squished, they can just move around and match the shape of the mouth, even when I'm using a lattice deformer like this. Anything else in here? Normalized range, we talked about that. We're using animation. Guides and live guides. So probably most of the auto riggers that you guys have worked with go kind of like, I don't know why my tablet keeps turning off, but it works kind of like this, where you would set up the guides, and then once they look good, it builds the rig on top. And then if you were to decide like, oh, my elbow pivot is a little bit too far forward, I want to move it back, you'd have to go through and export all of your deformer weights and export all of your blend shapes. Go back into that file you saved where it was just the guides, just the pivot, and then build again and re-import all of your skin weights and blend shapes. But there is an alternative to that, which is something called live guides. So say, for example, I was looking at this and I was like, oh, actually, I want the pivot point for this control to be somewhere else or oriented differently. All that I need to do is go to the guide that is paired with it, and I can move the guide. And what's really great about this system is that doesn't change how the deformation works. So even though the orientation of this control has changed, that's entirely separate from how the deformation works, because the deformer is not related to the orientation of the control, it's just related to the surface. So that's helpful on little controls like this, but you can do that on the body as well. I think somewhere on my website I have an example of a leg component. Okay, let me see if I can pull that up quickly. G-Craig. Really, is that not on here? Oh, live guided and localized leg component. Oh, I just have to download for the Maya scene. Well, it's basically a setup where you could adjust just a locator for the elbow, and it would interactively be changing the pivot point for your rig. So you never have to go back and rebuild, and you can do little tiny adjustments to the pivot point for all of your joints. And just as you're moving the guide around, you can just see like, oh, does moving it this way make it look better? Does moving it that way? And you don't have to, iteratively build. If you're interested in learning about like the live guide stuff, there is a YouTube channel called The Cult of Rig. If you haven't already watched some of those videos, I would highly recommend it, because the person who made that, he worked at, which one was it? I think it was Animal Logic, and he's a very smart, like technical 3D artist. So he really does like break it down. He's like, this is the way that I do it, and this is why I do it, and you get all of these advantages. So he's one of the people who really preaches for the use of live guides. And like live guides can also work for these surfaces. So I could go into what we call like the interactive bind mode, where now it will let me edit this patch. And I'm going to just make it curve out like that instead of straight down. And if I move the control, you can see that now, instead of going straight down, all of the points slide along my newly shaped surface. So if you were trying to decide like, oh, do I want like the points of my brow to just travel straight down, or do I want them to maybe angle in slightly just because of the shape of the character's head? You don't have to, decide on that right away. You can sort of just fiddle with this surface until you get something that looks exactly right. And it is very helpful to cut out all of that exporting and rebuilding time. Weights, parameterized deformation, we talked about that. Deltas, remapping deltas. Right. So if I were to, have a fully polished character's face, or even a body, and then I wanted to start a new one, first of all, of course, you would want to stay with the same base mesh unless you really have to change it. But there is a lot of stuff that you can get for free. For example, if I were to take this character, just, duplicate them and just start, smushing them into a different sort of character design. There's only really 3 steps that you have to do to build your new character. So you have to, of course, place the guides, like where is the surface and where are all of these controls going to go. And then you just have to paint weights and you have to sculpt. So we have a system where it will remap these guides to this new mesh. And the way that we do that is actually pretty crude, but it works really well. Can I zoom out here? No, it's fine. So say I take a character like this, and then I've got a different character with a slightly differently shaped head, but it's the same topology. What I do is for each guide, if it is like a NURB surface or a NURBS curve, I just leave it as is. So let me just draw in a NURBS curve, sorry, NURB surface guide. And if it is a locator, I just create one of those little NURBS patches for it. And then what I do is I create a lattice deformer around the head that affects, all of the guides, so the little rivets, all the NURBS curve guides, and all the NURBS patches. And then I will wrap that lattice to this face mesh. So when this face mesh gets distorted, the lattice gets distorted, which distorts all of these other guides that are within the lattice. Then when I blend shape this face to that new one, the lattice moves with it, and the lattice pulls all of the surfaces and the curves and the locators with it. And what you end up with is those same locators and rivets and all those little guides, but now they've been fit and stretched and like repositioned to fit to your new character. And in the tests that we've done, you can get probably about 85% of the placing guide work done for free using a system like this. So it's mostly just going in and like fiddling with the little points or a few of the locators that might not be placed exactly right. But obviously saving 85% of the placing guides is a lot of time save. When you're wanting to reuse the weights, like I talked about, all of the deformers on our face are parameterized. So, because the surface is fit to the head, we can use the same weight map on different characters, even if their like proportions and designs are different. The same weight map will still be pretty good on all the characters, and you just have to do that fine adjustment. So, there's technology that saves you time setting up the guides. There's technology that saves you time painting the weights and doing the deformations. So the really only remaining thing is, can we tackle the corrective blend shapes, like the blend shape sculpts? And the real challenge of that is that Maya stores corrective blend shapes in global space. So for example, let me delete all this if I can. I can't. If I had a cube or a square just like this, and I took those 2 points and I translated them out in this direction with a corrective blend shape to stretch the box. Then I had another square like this, and I just copied the deltas directly from this one to this one. You would hope that Maya knows to move it in this direction, but unless you've transformed this box using the rotation channel, that's not going to be the case. It's just going to say, okay, you want it to be translated in the same direction it was before, like this. And so once you go from like a simple case like this on a square onto a face where the lips might be angled differently, or the jaw might be lower and rotated slightly, and eyes could be angled differently, all sorts of things, this can cause a lot of problems. And I have some visual representation here. So say, for example, I were to go from this character to this character with a blend shape. Obviously, it's the same mesh, but because kind of his whole lower face is angled differently. You can't just directly copy the deltas. And this is what happens if we do try to directly copy the deltas. I pull out his lips to have him kiss, and it travels in this direction. And when I copy it onto the distorted version, still try to move in that direction, even though logically we know it should move in this direction. One of the things that we can do to get around that is we find what are the vector of those blend shape deltas. Instead of in world space, we find them relative to a specific NURB surface. And since we're using NURB surface on pretty much all the deformers on our rig, we can just use that to remap the deltas. So kind of relative to the surface, it's moving in this direction. But now that the surface is curved like this, it remaps to be moving in the correct direction. So you can see here is like the bad result that you get by default, and then this is the corrected result. So that's just a time save that I wanted to talk about, like a technique that can save you time when reusing deltas between characters. That was everything that I had specifically written down. But if you guys have any questions about those sort of techniques, like how those custom deformers work, or just the type of work that I've done, feel free to ask. Now's the time.
When you mention like these custom deformers, is that stuff that gets written, or is it like, so it's not stuff that comes directly in Maya, stuff that your team has kind of like built?
So these custom deformers are stuff that I've done sort of in my personal work. So I can give that stuff to you guys to test if you're interested in trying them out. But obviously, like, I wouldn't recommend using them on like a student production, just because the difficulty of making sure that everybody working on your film has those plugins. But that stuff is all available to you. Yeah. If you're interested in learning how to write like custom deformers or custom nodes, the thing that you need to look into is called the Maya API. Have you guys heard of that before?
Yeah.
Yeah. There's a Python version and then there's a C++ version. If you just like start testing out the Python version, that one's a lot easier to get into. And then once you're more comfortable with that, you can maybe decide to jump into the C++ one. Obviously, like that level of sort of coding is not something that every rigger needs to know or is interested in knowing. But if you know how to use the Maya API, you'll certainly be a rigger that's in demand because there are not many people that know how to use it.
And I had one more question. So how much of these techniques can be carried over into like making rigs for games, like, and that will work in a game engine?
So there is something called Ozone. So Ozone is like a face and body rigging system that is in development for Modo, and it's done by a guy named Richard Hurry, who he used to work at Pixar, and then he left to basically do this. So he's basically taking all of the stuff that he learned at Pixar and he's applying it in Modo. But what's really great about this is Ozone can export a rig that you've done in Modo with all of these, like, he's got the same sort of custom deformers and live guide setup that we have, but you can export it to Maya or to the Unreal Engine. And I think that he was talking about expanding that to some other engines. So if you're interested in doing this sort of thing for game rigging, I would definitely look up Richard Hurry Ozone.
All right. Awesome.
Yeah. If you're interested in doing this sort of technique without those like custom deformers, there are lots of studios that do that. This is obviously like some older work from Sony, but this is a demo reel from one of their riggers, and you can see that they have individual joints that are just attached to a point on his face. And then it's those joints sliding around on a NURB surface that is shaped to his head that actually makes them get these nice poses that keep the silhouette of his head nicely. So you can do something sort of like that where instead of, having a custom deformer that slides points on the surface, you just have individual joints sliding on the surface. That's what I did when I was at SCAD, kind of as a first step to try and replicate this sort of work. And that's how we did the My Little Pony movie. So you can 100% get great results just using joints on a NURB surface. But of course, having just one deformer that does it all for you without any complicated setup is better.
Well, I'm thoroughly overwhelmed.
I know it's certainly a lot different than you are likely to have seen previously.
No, but yeah, this is cool. This is like my horizons have been drastically broadened.
Yeah. Oh, one thing that is not in this rig file because it's still in development. Have you guys seen like Pixar DreamWorks demos where they don't have controls that they're clicking on? They just click on the mesh itself.
Yeah.
What is the name?
That for How to Train Your Dragon 2, right?
Yes. So that is probably going to be coming to Maya in maybe the next year.
Yay.
Well, I have the name of what's the guy? It's like Bitstream or Bitcube. I have it written down in some document here. Does anybody know which thing I'm talking about? You might have seen the demo on LinkedIn. Bit Studios. This is not it. Oh, right, it's Square Bit. There we go. Right, so this is a ex-Disney TD who is basically, stealing some ideas and implementing them into Vanilla Maya. So it's exactly what you've probably always wanted, where no more controls cluttering up the rig. Just click on the mesh and move it around.
That's cool.
Yeah. Before he had released this, I had done an attempt at trying to replicate it because I'd seen it in the same sort of demos from Pixar and Dreams. Turn that off. Is that in this? Yeah. So I was able to get, something close to it, with the deformable controls. But obviously, when you're looking at it in a demo reel, I'm hiding all of the problems. But if anybody can figure out how to do it in Vanilla Maya, it's going to be Squarebit Studio, so keep an eye on them. Oh, I had this open because I wanted to plug this. You probably, if you've taken rigging courses at SCAD, have heard of this book, The Art of Moving Points. If you haven't, this is like the only good rigging book. It's written by what did you say?
Oh, I just said facts.
Oh, I wasn't sure if you said facts like FACS or
Oh
FACTS.
no, not the UV face stuff.
Yeah, not the facial action coding system. But Brian Tyndall was the lead deformation artist at Pixar. So if you read through this, he'll basically tell you, like you're an idiot, like, this is why we put the spans where we put them. This is why we model it the way that we model it. This is the way that your controls should work to get, a nice animated and expressive rig. Like, nothing goes into more minute detail than this book. And it's good stuff because it's Pixar. Yep. And go online and look for. Oh, yeah. So, obviously, I'm not like the first person to come up with this sliding points on a NURB surface. You saw that Sony demo that did the same thing as well. But if you guys aren't, taking a look at the sort of SIGGRAPH or even just tech papers from Disney that come out every once in a while, you really ought to do that. Because, like, even this recent stuff, which is from Blue Sky Studios and Spies in the Skies, they talk about doing the same sort of technique to, like, slide the wings along the weirdly shaped bodies that the pigeons have, or using sort of like surface wrapping cool stuff for the wing rigs. And a good trick that you should learn how to use is if you find like the name of the paper and you find it on a website that says like, oh, you gotta pay $10 to read this. Usually what you can do is if you just look here in the publication and see like, oh, SIGGRAPH 2019, you can get to a page like this where it just lists all of the things that are going to be presented there, and this will give you access to those for free. So you can read stuff like this about Spies in Skies or Charlie Brown. Any other questions, topics of interest? I mean, you're all obviously free to message me on Discord after the fact if you have questions or are looking for feedback. On a scale of 1 to 10, how do people feel like this is over their head?
It was over the moon for me.
Hi, I'm a member of this union who doesn't do any rigging. That's how over the moon is.
But are you interested in rigging?
Somewhat.
Yeah. I mean, so something that you might want to be aware of is, like, obviously when you're at SCAD and you kind of have to do everything by yourself from scratch, like if you don't have some level of technical skill, it can be very hard to rig. But at most, like at least at like feature film or visual effects studios, they have really robust tool set set up and they're very artist friendly. So like in this sort of setup, even if you don't know how to rig, like you know how to make a surface fit the shape of a character, and you know how to paint weights and sculpt points. And that's literally all that you need to know how to do. Like, I've worked with probably about half of the riggers that I've worked with at the 2 studios that I've worked at had no technical rigging skill. Like, they couldn't code, they didn't know how joints worked, but they just had a really good aesthetic sense for like sculpting. Like, they were primarily modelers. But when you have a setup like this one that's really artist friendly, even if you like say like, oh, I'm somebody who doesn't rig, like, you can still be like a character artist.
Hello.
Well, you know how to code, Jules. At least a little bit.
Yeah, true.
I guess one question I kind of it's I don't know, it's probably a hard to answer question, but for like some of like your projects that you're kind of going over, because I was checking out your website a little bit, just kind of like seeing some of the stuff. It's like, I guess, just where do you sometimes get started on something that just like you don't really know anything about?
So maybe a good example of that would be like this Translate Uvn Deformer, because that was something that I like read about in this paper from Blue Sky, which is from when? 2015. So working on it for about 5 years. Because like, obviously this is stuff that's being done by professional TDs at a feature film studio, and I was reading this as a student. But sometimes it's just trying to figure out what is a step in that direction, even if you don't necessarily know all of the steps beyond that. For example, when I read this, I'm like, oh, so it's a custom deformer. I like just Google like how to make a custom deformer in Maya. And so that I find like tutorials, it's like, oh, this is the Maya API. Like, you should learn how to do it in C++ if you want it to be like faster. And I'm like, well, that seems a bit difficult. It's like, or you could get started in Python. I'm like, okay, let's get started in Python. So I set up a project for myself to learn the Maya API, which was, do I have that open here? A set of scripts called the Deformer utils. This is not the right file. Deformer. Oh, sorry, weight utils. Called the weight utils. And so it's just a whole bunch of functions that let you, edit and work with weights. Actually, it will probably make more sense if I open up the UI that I did for it. But this was sort of a project where I was like, oh, my API for Python seems really good for, even just like getting attributes on weights quickly. So I just used that as an opportunity to kind of learn how to create these different functions. Like, I thought, oh, I've learned how to, just get the weights off a deformer using these commands. But I wonder how I would go about, making those weights symmetrical. So I like read up a little bit on that, and I learned how to do math in the API with comparing the points and things like that. I don't know, is there like a project specifically that you're trying to work towards at the moment? Not sure where to start?
Kinda, yeah. Like, I was challenged to write a script that allows you to change the color of the keyframes in the timeline editor, but like change only specific ones you have highlighted.
Okay.
And it's just kind of like, it's like something like for that, for example, it's just kind of like, it's just like a general idea of like where do I even really start looking for stuff like that?
Yeah, so I've never actually looked at that. You said the time editor? Or are you talking about just like the time slider
Just
here?
the timeline, the slider, yeah.
Okay.
So if you were to like set a key at like frame 30 and then have one at like frame 59, it's kind of like if you could like somehow change that little red line to make it like blue and then make the one at 40 like green or something like that. I think that's the goal.
It's an interesting idea. So usually like the first thing that I would do is I would try to see if there's a way to do it manually, like without using a script. Do you know if that's possible?
I think it is. So it's like Professor Ahmed gave me this challenge, and it's just kind of like the thing about it is I think there is a way to do it manually, but the only thing that does is it changes the color of every single key in the time slider, and it's just kind of like a challenge for you is to like make it so that so you can just select like whichever key that you have selected, you can change the color for that one.
Yeah, because usually what I would do if I'm trying to script something up is I would just like do it manually and see what sort of commands are being called here in the script editor, and then just sort of reach search into that. For something like this, though, I'm not sure if anything would show up if I were to change. I got the time slider key. If I were to change a value like this, you can see update RGB color time slider key. So like this, it seems like it's the only command that's being used. So you could maybe search that into Google and dig into it that way. To be honest, I'm not sure if that is something that Maya will let you do.
Oh man.
But this is where I would probably begin. Like I would just search for what is the full command there. Update RGB time slider key. I'm not gonna like dig into this too much, but you might see things show up there. And there's also the Maya programming forum, which is kind of explained weird. So yeah, if you come on here and just post a question, somebody might know. Sometimes you post a question that's just sort of very left field and people haven't thought about doing it before either. Like I've never thought about changing those colors individually. Or like here, I asked a question recently to query if an attribute is paintable, and no replies because nobody has really needed to do that before, apparently. Bit of a long-winded, maybe unhelpful answer, but
No, I get it though.
definitely an interesting idea.
And I guess like for like other things, if it's like something like that looks really interesting, I'm probably going to be reading it from some sort of like resource that must have some sort of information that can kind of give me a lead onto it.
Yeah, usually if you can find like one thing that seems to refer it, there's like a paper trail that you can follow to eventually figure it out.
It's like an investigation.
Absolutely.
Detective.
Any other questions from people? Otherwise, I'll let you go instead of keeping you hostage.
What's one of your favorite things that you've made?
One of the favorite things that I've made. In terms of like character, in terms of like tool development.
Like in like tool development.
I would probably say either this Translate Uvn Deformer that slides points on it, or there's actually kind of a hidden thing that's going on here. Because the brows are not just like translating on that surface, they're also like doing twists and other things as well. It can be quite computationally costly to do multiple calculations involving the surface. So what we do is we kind of remap the points based on their UV coordinate down here to just a flat plane that runs from 0 to 1 on the X and Y axis. And then if I can grab a control while I'm down here. Shading wireframe shaded. We do all of those deformations from pivots that are down here on this flat sheet. And then once we're done moving it around in that flat version, we have this other deformer called Convert from UVN, where using that surface, we convert back up into 3D space. That's actually what they did on the Charlie Brown movie. I don't know if I can find it. It's a UVN deformer. Charlie Brown. Let me get to the right thing. I know that they've released some stuff from it. But basically, like on Peanuts, obviously they have very specifically shaped round heads. And so they didn't want, when you like translate any of the features around, that you see like it breaking that silhouette at all. So they were one of the first people to invent the UVN transformation stuff. So they were literally taking the faces and almost like UV unwrapping them to create a flat version. And then they would do like joint transformations or blend shapes in that space, and then rewrap that onto their spherical head so that any movement they did on that UV space could never even potentially break the silhouette of the character. So finally figuring out how to do these custom deformers, it was a multi-year journey of learning new skills in Maya to finally get there. So that's my favorite.
Yeah, congratulations on that.
Yeah.
Favorite.
I guess one other thing is, it's like, I guess do you just like, for just kind of like learning new things, do you sometimes just like look at articles, or does like look at something and be like, hey, I want to be able to do that, and so you just kind of like set yourself on a project to do that?
Oh yeah, I think that they actually have something in here, if this is the right paper. Right. So I was reading this one from Blue Sky. And so Blue Sky did the UVN deformer on the Peanuts movie. And then here they're talking about a proprietary deformer that allows deformation to take place in UVN space was updated. A new mode was added that allows the long flight feathers to maintain their shape in Cartesian space while being driven in UVN space. So basically, the feathers would shape to just like one nice smooth surface. So they keep like a nice silhouette, but the feathers themselves wouldn't stretch because that would be ugly. And I was like, oh, that sounds very interesting and very challenging to implement. So sometimes I'll just read something like that and I'll be like, that's something I'd like to look into. So if you look at these sort of like SIGGRAPH papers or see something like this on LinkedIn, it's worth looking into more. Another good thing that I used to do is just go on like Vimeo and I would search rigging reels and look at the ones that have been posted in the last week and just see if there were any interesting tools on those reels.
All right, cool. Thanks for the info. I'll have summer break that could just kind of like steal.
Yeah. I hope that you guys are aware of the resource list. Do you guys still use this? The SCAD rigging resource list?
I do.
Good. At least somebody does. But yeah, it's got like blogs from a lot of professional riggers. It's got some of the links to where those tech papers are. Like if I were to click on here, oh, let's see what's up at Pixar Graphics. So they've got like, oh, a lot of dynamic stuff. This was very cool. So I don't want to keep people that aren't so interested. But, you know, once you've got like deformers and weight maps and everything else going on, sometimes that can be that can slow down the rig if you get too much of it on a complex character. But Pixar is doing research into like machine learning where it will come up with a small set of blend shapes that basically replicate all of the deformations that the like deformers and the controls make, but without getting like that volume loss that you often get when blend shapes interpolate. So that's what like the artificial intelligence is coming up with. So like they're showing off like here's what the rig with everything going on looks like. And then they've got just linear blend shapes. And then they've got their new custom AI method. And, you know, you can see in some areas where the rig gets really extreme, the linear blend shape kind of fails. But then their new method, like I can't really see a difference between these two. And so once they bake that down into blend shapes, it's just like wicked fast. But obviously it has to be, you know, perfectly replicating the rig. So this is a good resource. You can look at everything. I'm just kind of going through interesting things out. This is even just a fun paper to look at because they show how they've used the same mesh to get different character designs. So they've got the one mesh that they use on all their characters, just morphing in between them. Which is very cool because it kind of does surprise you about the amount of visual diversity that it can get without changing the mesh that they use. Love rigging, love rigging.
Oh yeah.
And where can we access that?
Sounds like an absolute life hack.
What thing?
The Pixar like singular mesh thing just sounds like an absolute life hack.
Oh, for sure.
Mm.
But for any of you who are also modelers as well, like any knowledge of rigging when you're a modeler can be very helpful because frequently we'll get models from the modeling department. And so obviously you want like the same number of spans on the top and the bottom lid. They'll like take this span from the corner. If I can select that. And they'll like twist them so that the wrong span is being used as the corner. And it just becomes a fight because we're like I know that it looks right, but like the mesh is wrong. Like you gotta just slide those spans. So even if you're using the same mesh, sometimes those wacky modelers, they can still Oh, that's maybe something minor. Rigging with the eyes open versus the eyes closed. I'm going to come out in strong support of you got to rig the eyes closed. And the reason that you should rig the eyes closed is because then you can get stuff like this where you can have them close in any shape and it just stays clean. But if you rig them open and then if you rig them when they start open and try to like get them to seal properly, dicey. So I'm on team eyes closed.
That's good to know.
I do know that at Naughty Dog, they rigged them half open and half closed, or at least they did before. Maybe they've changed that since.
They're out there making the really hot takes. They don't choose either side.
It would like, how can I remember the name of Last of Us rigging? Yeah, Judson and Tav, because this is a very good demo as well. But he's saying like, yeah, we rigged the faces with eyes half closed and mouth open. So he gives some like good reasons. So he's saying like, I'll have normal sampling to be much better on eye crease for like texturing and things like that. And it's also sort of like a more neutral one, because when you're doing a game rig, you're pretty limited. So you want to kind of put your neutral model pose to be pretty close to the middle of the range it'll be moving around in. Like that's why they model it in A pose instead of the T pose, because most of the time your arms will be moving around in that lower range, and they don't have the computational budget to do like corrective blend shapes on all of the shoulder poses. This has turned into less of, let me show you some cool facial rigging, and more of, let me just show you some cool stuff that other people have done.
I guess if no one has any questions, that was a great presentation. Thank you so much.
Yeah.
Yeah,
Nobody has questions about the My Little Pony movie?
What you do?
What?
What you do? What did
What
you
movie?
do? My little pony. Yes.
So I did the body on this guy Hitch. I did the rigging design for these straps on electric ponies. It's that same sort of deformation rivet where it follows along with the skin cluster. Yeah. And I did her hair and her body, and I did most of the facial rigging dev on all of the characters. And then there's 2 more characters that they released since I put out this reel. Gonna be dangerous going onto equestriadaily.com.
Careful now.
Don't worry, I'm being careful. I'm moving very fast.
Run.
Yeah, so I did like the wing design on this character, and I want to see the actual 3D render because that puts it in context instead of fan art. My goodness. This is getting too dangerous. I can't go too far into this website.
The Geiger counter's going off.
I think that it's. I did the one with the mohawk, and I did the one with the pink one with the tiara. I did her wings and her body as well. And I did the villain that hasn't been released.
There's a villain?
There's a villain.
NDA, spoilers.
I'll
Is
drop
it growing
the.
apart after knowing each other for a long? Because it's the opposite of friendship.
Oh, like is it a metaphysical villain? No. I can probably tell you because it won't make sense. I'm going to tell you that the villain is a JoJo reference.
Oh my god.
So
Really?
So you haven't seen him, so you don't know what that means, but something to look forward to.
Oh my god.
Now you'll be looking at Equestria Daily every day to see if they've released them.
There's the JoJo reference, My Little Pony character. That's basically all. That's what the search history is going to be full of. That's great.
Yeah. There's literally nothing about the character out there, though. It is funny to see people's speculation. They're like, "Oh, I heard that the villain's going to be like this." I'm like, I know for a fact that it's not.
Like, they're not gonna believe you if you say it's good. It's a JoJo reference. So
Yeah, I could post like a design document or an image of him and said, "Hey, look, this villain is a JoJo reference." I'd be like, "Yeah, that's some fucking bullshit." I don't think the higher ups at Hasbro knew that it was a JoJo reference. The character artist just snuck it in there.
Amazing.
On that note, leave.
Dismiss.
Jesus, I guess when you work in the industry, you just get to do that. That's fair
No.
enough, I guess.
Nah, you guys
think
can
you
hang
would
around
enjoy
in the
that.
Discord chat if you want to, but the presentation is now over.
thank you.
Yeah,
It was a
thank
great
you.
Thanks so much for
presentation.
thanks so much
Thank
for
you.
doing this show.
No problem. Feel free to bother me later.
You know I will.
You're gonna bother me right after this.
Yep.